going to be my cold open. Lukas saying differential equations are not hard.
It's easy. Fourier transforms, multi-order. Yeah.
Welcome back to Helical Brew. This episode is part of our AI Thought Leader series. Today, Lukas Bromig explains why standardization comes before intelligence.
Welcome, everyone, to another episode of the Helical Brew. Today, we're joined by Lukas Bromig, who's the co-founder and co-CEO of UniteLabs, based out of Munich. He's a doctoral researcher from TU München, which I've had the pleasure of visiting a couple of times in my travels to Germany. And this episode is going to be talking about the foundations of AI in the lab and all the tools and software and things that need to come together to make that work. And so we're going to title this episode, Standardization Before Intelligence, Building the AI-Ready Lab Stack. So welcome, Lukas. And, we always like to start the show with a bit of a icebreaker. And I've got a few to choose from here, and I've already chosen one. To kick things off, and this can be a theme throughout the show as well as we're talking more if we want. But what's one standard labs argue about endlessly that actually shouldn't be controversial?
It shouldn't be controversial. To me, that's quite an obvious one. Also, it kicks home. I would say Zeta 2.
Okay. And any insights as to where the controversy that shouldn't have happened? Maybe an example?
Yeah, I mean, right now, if we look into the lab, every device has a different interface. And I'm not talking hardware interface, like one comes with an RS-232, a serial playing a DB9. But then it's more about the communication protocol. And yeah, it's different for every single instrument. Every vendor has their proprietary interface. And if you want to connect anything, you have to deal with, a million different ones. So it just feels natural that, there should be some form of standard behind that so you can plug and play. I mean, if you're looking at Bluetooth speakers, they managed to do that. If you look at USB communication, they managed to do it. So why can't we have that in lab automation?
Yeah, for sure. It's like a headset on a Bluetooth speaker, or headset function on a Bluetooth speaker is a function that's got standardized at the top level. Why can't we have that for a lot of these data interfaces? I hear what you're saying. You can definitely feel the made in a vacuum effect of a lot of this software packages. So that'll be a great item to dig into deeper during the podcast here. And so I was reading on your website a bit, just in my research, UniteLabs, for everyone, Lukas's company. And, I saw a lot of really great keywords. I'm just going to read through a few of them here, but a lot of like nice highlights as you're scrolling down the website. Connect anything, automate everything, and also, what was the other one? Oh, close the loop between data and action. These are all things that, as a controls person, somebody coming from the robotics industry, that's my ground up. I started with a company near Zurich called Stoibli, the beginning of my career. Closing the loop was just a matter of making a robot run really well, but it's being really brought up to the level it needs to be at to actually automate science, not just automate moving things. So this is, for me, I think one of the most exciting times in laboratory automation, and really looking forward to taking the deeper dive with you. So why standardization is the real bottleneck? I want to talk about that a little bit with you, because I think it's a great baseline for a lot of the things that are happening right now in the industry. And we're relooking at standards that exist. We're also creating new ones that have made sense for years, but for whatever reason, never got the traction it needed to. Where do labs actually break down today? Device integration, data structure, scheduling, or ownership, or all the above?
I would say all of the above. I mean, they're all unique challenges that keep them busy.
Take a deeper dive on that?
Yes, definitely. So maybe taking a trip back down memory lane. So during my PhD time, I was tasked with integrating a complete greenfield lab. We had everything in there, from large-scale bioreactors, liter scale, and even larger. But we also had liquid handlers and robots and balancers and peristaltic pumps. And every single time a new PhD student started, they had to build their own experimental setup. And typically what you do in R&D, and this is also quite common in industry, is that you build something very, very custom. You have a very unique experiment that you want to do. And then everyone had to kind of reintegrate these instruments over and over again. So the same work was just done a million times over. And if you now look at all the different people also in this industry, if you look at the large corporates, the startups, if you look at integrators and academia, everybody is rebuilding the wheel in a way, building the same integrations to the same instruments over and over again. We actually had a look at the instruments that are actually relevant for lab automation and came down to a list of around 1,000 instruments that are actually being used that make up 80% of the use cases of the work cells and the experimental stations. Why can't we consolidate that effort? Yeah, when you look into that, you come across the standards and you realize, well, everybody actually needs the same thing. Also for us, from a company perspective, we think, like, what's the common denominator that makes up the infrastructure that a lab requires, the thing that is not unique, that is not custom. And this is kind of where you start. So everything actually we look into is kind of bottom up. So whereas a lot of companies that start, or even like in academia, you typically start top down. You have a problem and then you start integrating, but you always have this one use case, this one application in mind. And oftentimes that kind of pushes you towards not doing 100% of an interface, maybe not doing it in a way that it's reusable, that you can kind of maintain it, but it's made for one very specific purpose, maybe for just like one campaign. And then afterwards, well, someone else comes and has to pick up the pieces.
You own it now. Here, I have a gift for you.
Yes.
Enjoy this driver. Yeah, I think we've all been there, right, Sura? You know, having to take on somebody else's science experiment, perhaps in a lab, as far as software or an integration or something like that, and having to own it and then perhaps even redo it depending on the situation.
Yeah, and I think the key is with everything that's happening in technology, you are finding that when there is no standardization, that really highlights the issues that are going to be coming, right? And so what I find is, exactly what Lukas said. They try to add different new trendy technology before they even look at what is that foundation? Are we able to add things like intelligence before fixing the inherent gaps and, disconnects in the foundation of it all?
And then maybe coming back to the data structures that you mentioned. So when I look at standardization in the lab automation space, I see three different types. So the first layer that I think should be addressed is the interface, like device communication, a standard for that. And then after that, there's kind of the data standards. What should the data be structured? And I'm not talking about the format, like is it a CSV file or an Excel file? I mean, that should be homogenized anyway, but it's about like, if you now say, okay, let's go for JSON or XML, what should the structure of that data within that format look like? And there's a few standards out there, but then I think that is actually a really difficult one, because typically if you then go to the larger companies, they have some very unique needs and then they typically extend their structures. But now, if you look at the structure of your data, if you really add a lot of fields for metadata, for context, this is kind of then the foundation for any AI effort. So if you have the device layer standardized, then AI can suddenly move things. So it can understand what the devices can do and it can actually execute. And you can go from pseudocode to actual executable code. If you then take the next layer and look at the data standards, you suddenly have structured data that an AI can understand, that an AI can interpret and compare also between instruments. And then the last layer that I see is workflow definition, like common language for how to define these things. So also, if you look at it top down in the lab, you come from standard operating procedures, from protocols, from long text files. And there's nice libraries of these out there, like protocols.io, but there's no common standard. And there's a lot of companies out there that are kind of doing that. It's like from voice, from an LLM to kind of a structured protocol. But then if you want to turn this into executable code, you actually need to build an actual language behind that. And that requires you to look at ontology, at the structure of what are atomic actions across different instruments, what are device types, what are classes of devices. And then this turned into a very scientific question very quickly.
And it's definitely something that, most labs, when they get to that stage, maybe don't think about it. We come across a lot of folks that just want to integrate it, like just integrate this, right? And there's just so much to that statement. And I think that's what we find in our role to be a little bit of a dangerous phrase, because it's not taking into account everything. Do you find that to be the case as well?
Yes, definitely. And also, like if you have a lab and you want to build something, like you shouldn't start getting sidetracked by something like that, because it's a huge effort. I mean, you can look at the large cloud labs like Emerald or Strategist. They've come up with their own language. There's open source projects that are trying to define this workflow notation. And it's incredibly difficult because typically you are in your own bubble in a way. So what I realized also coming from bioprocessing and chemical engineering at first, they're entirely different needs for those areas. And then you're totally unaware of, for example, high throughput screening.
Yeah, you've got blinders to your
Yes.
own.
Yeah.
Yeah.
And then if you define your workflow notation for your domain, then it's very likely not compatible with another domain. So you need to take 10 steps back and look at the industry as a whole. And this is incredibly difficult. And I think you can really get sidetracked if you try to build this bottom up.
Yeah, it's really interesting because I'm hearing things, we're really looking at similar bottleneck things that are solvable from different angles. I look at it more from the product perspective as opposed to the scientific execution, but they're the same problem. Ultimately, it's how many assumptions do you go into, or how many black boxes are you free to create along the way where, it's kind of like, nobody really thinks about the TCP stack, underlying TCP stack in a Mac or a PC, right? Because that code has been beaten up billions and trillions of times. It's solved, right? And there's a lot of things we can solve in the same way that we just assume we have to create something new for, and we don't. That also is true with robot interfaces. Robots are kind of unique in the world of lab automation, and that's not a data-driven device. It's not necessarily even a workflow-related device because that's handled at the higher level. It's more of a, how do you talk to the robot? And, there's a lot of variability there, but one thing we did was he said, we're going to take software out of the equation. Everything is over TCP, right? And starting there, using the reliable things. But yeah, I see a lot of those similar things. I think we answered the second question I had, but I'll point it out anyway. I mean, why do so many lab automation projects stall because of just a few instruments? I think you hit it on the head. It's well, every instrument it's a sidetrack waiting to happen. It's a detour. You're like, I didn't expect to spend 3 weeks just trying to get this box actually set up, because I saw it in my friend's lab and theirs was already running, but who would have assumed it would have taken that long to get it working for whatever reason?
Yeah, I think you mentioned something that quite resonates with me, and also the messaging that we try to bring to the industry is black boxes. Right now, if you're trying to set something up, there's so many black boxes because there's so many silos, so many proprietary software systems. So if you're trying to set up, say, a work cell, it's not like you deploy one piece of software. The current status quo in the industry is that every plate reader, every even thermocycler, every liquid handler definitely, and even robots have their own black box, and you have to develop methods in each one of those. And then when you want to deploy something, you actually have to install drivers. You have to install each of those softwares. Everything has to be compatible. And in the end, there's some orchestration layer on top of it that has to make sense of all of that and has actually zero visibility all the way down to what's actually happening in these methods. So there's no actual state. You don't really know what's happening. It's just you trust that thing, you fire it off with some parameters, and then you don't know what's happening.
Yeah.
And this is also something that we're really trying to tackle, to break this up, to actually build an operating system that gets rid of a lot of these, of this fickle landscape that falls apart like a house of cards.
Yeah. I think the terminology you're using is perfect, operating system, because at the end of the day, what I referred to about, just the simple things like sockets and standards, it's part of an operating system, and it's something you can get a ton of data about as to how well it works and what needs to be improved and all those things, as opposed to, yeah. Go ahead.
Yeah, and if you look at it as an operating system, it's also quite nice because everything becomes code and you can actually deploy things. So right now, like, this deployment thing takes forever. It's a very much a project business. And that's why projects take so long. But if you look at it from software, you can just, on Mac, you can do brew install and it's installed. This is not possible right now. You have to come in with a USB or flash drive.
Well, when there's no standardization, back to your point, you have to have trust because everything is sort of coming across differently and you're trusting that top layer to actually speak to everything. So there definitely is a need, right? Because as scientists, as engineers, we want proof. We don't want to have to rely on faith, right?
Mm.
And I bet there's a push with a lot of new technologies. I mean, AI is going to be it's a part of our discussion today, and AI being driven before the foundation is ready to handle it, right? I mean, can you speak to that a little bit and what your
Yes.
research has found?
So let's take a step back and go back to the SOP. You have an SOP, you can take any off-the-shelf LLM and ask it to generate code for that. And it will do so, but the code won't run. It's just pseudocode. It will show you the intent, like, okay, yeah, I'm going to do a PCA cycle, so there's no kneading step, like and so on. But you won't actually be able to run that in the lab. So right now what we have is a huge gap between this digital world and the physical world of the instruments, because there's no translation, no mapping in between there. And it's the same with protocols. Like if you have protocols, it's a black box. If it's a liquid handling method, it's a black box. The AI won't understand it. And what we need to do is basically build a layer bottom up that is actually code that is then that creates this mapping that you can hand over to an AI, even like an off-the-shelf LLM, to use that for teaching. And it knows if I run it that way, it will actually execute. And if you have an operating system, this is what the operating system provides you with. Well, then I also needs then also to technically run experiments. It needs full visibility all the way down to the plate. So I'm kind of dreaming of a world where everything in the lab is visible in real time to an AI agent. And in order to do so, you need to implement every single black box. So essentially what that means is you want to instantiate one plate, and then you will be able to move that from one robot to the next robot, to a liquid handling station, to a PCR cycler. And that should all be the same plate. You shouldn't have to jump out into a black box, parse a file, jump back into the next protocol, and so on and so forth, because then, you lose context. You lose a lot of information that you need to actually, we humans, we understand what's happening, but an AI won't. So we have to make everything understandable and visible to it, all the way down to the smallest well, to the smallest sample.
Perfect. I love how you put that together in a nice, short, concise thing. And so let's do a deeper dive on how we get there, and what are the things that need to be done, and some of the smaller problems being tackled today. What problem would you say are you trying to solve that existing vendors couldn't? Like, what if you were to pick one?
I would say bottom up.
Okay.
So if you compare us to existing scheduling companies or integrators or LIMS or LES, ELNs providers, then we are actually building an infrastructure layer bottom up. So we look at every single device and we don't go for the software. So let's say liquid handler, we don't go for the control software. We actually take that out of the equation. So think Raspberry Pi, Mac, Linux, Windows PC, you just plug it in and then you can actually talk to the instrument. And for that, we actually have now 5, in January, 6 liquid handlers at our office, because we're cooperating with vendors to directly control the instruments without the vendor software, to eliminate this black box. And what we then do on the other side is like, what's the language of AI ML? It's Python right now. Everything kind of revolves around Python. And this is why we built up basically a digital representation of the lab and provide a lot of that context. For example, labware, or the devices, or actually a liquid handling library as Python code. And by doing so, suddenly everything is in Python code, and you can give that to an AI and it will understand what's happening. And then, to my point with the labware, for example, if we built a labware library in plain Python, but all the way down to like the smallest geometrical shape, so that you can actually construct any piece of labware, and then you can calculate liquid level to volume to liquid level, and then you can create samples, and everything is kind of tracked. And then this is a piece of labware, this plate, is suddenly the same one that you actually instantiate when you're using it with liquid handler A and liquid handler B, and from a different vendor. It's the same entity. So you can suddenly start just owning one labware library, which makes things already much easier. And if you want to translate things, it also makes it easier. And if you want AI to help you with the workflow creation, it also makes it much easier.
Yeah, that's first step. It's like you start from scratch. It's true. Like every time you get a system in, you're starting from scratch. Got to add the labware library in for that particular system, even though it might be the same labware that's used 10 times over in the rest of the facility.
No.
Yeah,
that's great, because it abstracts some of the nuances that are unnecessary, because the consumable is the consumable, the geometry is the geometry. The pipetter needs to approach it the same way. Why do we have to recreate it on every single thing that's integrated together, right?
recreate and debug. I've seen, oh, I'm debugging this piece of labware on this liquid handler I've never used before. Well, that's
And that's the most frustrating thing is we can't, as, vendors, we can't be truly vendor agnostic because as soon as we get like an Agilent, for example, we have to build the labware for that. And then we have to switch it up for the links and then we have to switch it
Yeah.
up again for the Hamilton. And in the end, it's the same plastic. So that's great.
That's pretty cool. You're working with vendors at that level, especially the like liquid handling vendors, because to me, that's the instrument that's like the piano of the platform, right? What do people write music on? Pianos, right? It's often the liquid handlers where they're, writing something and then they expand out to other instruments as needed. But the pipetter is the one that you're always like, we don't know what happens after I send this file over and say go. I have no idea.
Yeah, I still remember the first time I saw liquid handler. I think that was back in 2012 at TU Munich, and there was this little tiny trade show. Like back then, liquid handling was not really big in academia, at least. But then suddenly, within the hall of our faculty, there were like 5 or 6 liquid handling companies, and they were showcasing these instruments, and everybody was like, "Wow, this is like the spirit of automation," and it was like really overwhelmed. And then now, today, I think that spirit is still liquid handling. This is also kind of why we started there, because we thought, okay, this is kind of the heart piece of any larger automation setup today. So this is also where the pain points come across the most.
Sure. Yeah, it's a little benchtop factory. It's more than just,
No.
nest out, nest in, does its thing. Yeah.
And nowadays we're not even not necessarily just looking at one instrument. So we've talked to companies, and some of whom have now also actually piloting our software, because they don't have just one liquid handler, but they have hundreds. Like there are factories out there. And you want to version control that. And as Sura said, like if you have a piece of labware and now you actually have to go to every single computer and update the labware library on that computer.
Oh, I never thought about it like that. Yeah.
And then if you have to do
and
that,
a simple like export doesn't do it. You still have to export, import still has bugs that you have to work out.
Yeah, then suddenly if you have 200 of the same type, you're busy for a week. And if you're running any form of diagnostics, you have, I don't know, 50 SX.
A week is kind.
Yeah, you don't want to do that. So there's just a lot of pain in that area that we see.
Yeah. No, I could see that. How do you think about standardization without killing flexibility for scientists? I don't feel like anything we've talked about so far it's actually going to expand the world for scientists. But I mean, I'm sure that can be a criticism, maybe, or maybe just a question that folks might present. I mean, so how do you look at that? How would you answer that if somebody thought, well, maybe this is going to, lower my ability to?
Well, people always think if I have to standardize, I have to be like locked in, right?
Yeah. It's a certain mindset you put yourself in. Sure.
Yeah, I would say that there was very bad marketing of Zeta initially, and also other standards, because I think it's a huge misconception. Just because you standardize the interface doesn't mean you standardize the features that are exposed. So you can say, yes, there is a feature that broadcasts its capability, and then you can, because it's standardized, you can actually on the other side, a client can pick that up, communicate it, because the way that it exposes the interface, the other side can immediately understand what it exposes. It doesn't actually tell you to standardize what is being exposed. So if one vendor has this very special feature that their hardware could do and that the competitor's hardware cannot do, they can still expose that feature, but in a standardized way. So to us, standardized just means that everybody knows how to communicate with each other. So it's the same. I like the smart home analogy. It's like you can have different smart home appliances. They're all, even like if it's the same type, but then depending on the feature set that vendor exposes, the interface will look different, but it will still pop up in your home assistant and you will know how to interact with it. So it doesn't actually cut down the scope and the feature set, and you as a vendor can still be unique. And I think the only thing that it's pushing now in the future is that vendors have to get back a little bit more onto the hardware side. Like their software game will reduce because they will be more ranked on the way the interfaces are built, because we are becoming more integrated.
What about scientists though?
I mean, the scientists would still have the same capabilities. So for example, the way we do our integrations and also the way we have built these connectors that basically expose the SLAS interface, they expose everything that the vendor software exposes and sometimes even more. So because we go lower, there's actually way more flexibility.
Yeah, I think that's the key that we should elaborate on, right? Because there's something that's more open to vendors, and then it gets sort of closed as the scientists get it, which is, it makes sense. You want to kind of be within parameters of what the machine can do. So I think that's where the standardization is feared, is at that level where a scientist or an engineer is trying to work with it and suddenly they can't, work on the back end to make the pipetter do something that maybe the GUI isn't letting them do, right?
Yeah.
Yeah, it's sometimes a tough sale, but I think the foundation though is where it's at when you look at just bringing things we work with every day and how you project the solution to customers in a way that they won't be like put off. And we run into that with robotics too. Like it looks complicated, right? Well, how do you take looks complicated into, it's actually not that bad when you put good software behind it, which is really what makes a robot easy to use, is good software. So a little follow-up question: how do European labs and US labs, differ from your perspective?
And I'm interested more in digital maturity, right? Because I think adoption is faster or slower depending on the cultural nuances.
I think I'll have difficulty to put all of Europe into one basket there. So I may be a bit more concise, because I think Germany is very much at the far end of the digital maturity journey. So within Europe, I think you actually see a trend that it's very much coupled to the cost of labor. That's kind of what it boils down to. So I think the most mature companies are basically located in Denmark, the Nordics, in Switzerland, Basel, and also the UK. And also for that reason, I think the US is way ahead. And then also, if you especially look into academic labs in Europe, there's oftentimes very little funding. Labor is extremely cheap. And this is why it hasn't changed much. It's also a cultural shift, because in Europe in general, I would say people are less prone to just adapt new things. This trial and error mentality is less present here. And then again, you can see differences between the countries. So the Nordics and the Dutch and the British, they're way more prone to just try out things more quickly and iterate, whereas the Germans are more reserved, I would say. And then if you go to the US, totally different game. Like, people just try something out, and if it doesn't work, they stop, they fail, they get back up and try out the next thing. So I think there's a big mentality shift. Yeah, I mean, we have 4 people from the US now in our team, because it's also quite difficult for us to find good talent that has this level of automation experience in Germany, because there are very, very few companies here that have really high-end automation equipment, and these data factories, what I call them.
Yeah, you can be in a city block in different parts of the US and work for 5 different companies, all within walking distance of each other. And that's true. Yeah, you see that.
We're also like rebels who like to try and fail rather than not try at all.
Yeah, that one's collecting dust. We tried it. We might go back to it, but yeah. No, I see what you mean about that mentality. And I also, the standardization angle too. I remember going to the Hanover Fair in 2015, and Angela Merkel was there, actually at the at the top level, somebody projecting things like Industry 4.0. I mean, that's clearly part of the automotive manufacturing culture, right? It's a big part of German culture, of course. And that was very interesting to see her actually on the show floor at Hanover talking about these things and talking to different vendors. Now, of course, it's all the politician thing, but at the same time, it was, we don't have it at that level. Like, you look anywhere else in the world, who does that? Nobody. I mean, I've never seen that from a state leader like that. But I think that I could totally see where you're coming from on that. And okay, moving on to AI readiness. I think, a lot of folks are like, hey, let's get some AI in here, but aren't ready. At the end of the day, they've maybe haven't thought through all that. And, also AI exposes some things once it is implemented, right? It exposes sort of this weak decision flow faster than it creates new capability. And that's just one of those things which I think all new technologies go through at some point, but AI, because it's moving so fast, we hear about the examples. The trial and error approach has never been executed more quickly, I think, in the history of a technology.
Definitely one of those things where, like, just trying to say you're AI ready, suddenly you realize all the ways you're not AI ready.
We went from Siri can turn on my lights to the thing's hallucinating in no time, from like COVID to now.
No.
But what does AI ready mean in practical terms?
I guess it depends on who you ask within the company. So the higher you go up, it's more about the data. Like, is our data AI ready? Do we have high quality data that has all the context? Can we use that to train a model? So there's a strong focus, especially on the higher up you go, on the data part. But then if you actually go into the lab, and to me, AI readiness is also, do you know what's actually happening in your lab? Can you actually talk to your instruments? Can you add in a co-pilot that helps you write methods? Can you have an AI that actually translates an SOP or that you can chat with to express your intent? And then that kind of helps you translate that into executable code, but that is also kind of safe and validated to run. These are more the practical things that you think of when you're in the lab. And I think AI is actually really great for the entire lab automation community, because suddenly everybody becomes aware that we are so not AI ready in most labs. So you want to build a model, and then you realize, I forgot to gather these data points, and I can't use that data that I've been gathering for the past 5 years. Yeah, I might have to redo that.
It's not ready. Yeah.
Yeah, so there's like
5 years. Wow. What a disappointment.
this huge drive on the one side that you actually now need a lot of data to train models that are predict new protein sequences, for example. And then on the other end, you realize, okay, you actually need automation because there are so many targets basically thrown out there that you still need to validate in the lab. So the lab kind of really becomes this bottleneck. And on both ends, just if you're looking at the data case, which is really great, because how can you solve that bottleneck? Automation, which is pretty cool. And this is why we also see a lot of these data factories being set up. So I think it's really great. And then as soon as you start building automation at scale, you also realize all the different pains that you encounter there that so far haven't been that painful, but now suddenly you try to dig deeper. Like, how can you actually iterate faster? How can we build methods faster? Because AI is moving super fast, and you have different times that you live in when you're in the software world, as opposed to the scientific world. Like so suddenly the software community is kind of pushing into the lab and saying, why is everything taking so long? Why are you not iterating? And then you realize, oh yeah, they're not using version control. Oh, they can't even use copilots. They have 10 different softwares that they need to learn. And then, I guess you just start hacking away at these problems.
So, I mean, let's throw it out there. What infrastructure decisions today will matter 5 years from now?
Not being messy.
Data that's useful.
I mean, the obvious answer is our tech stack, the one that we're looking into. One end is scalable connectivity. So we need a standard. We need applications that you can actually fleet manage, which are basically on all the different devices.
I like the term.
So, like, the way we look at things is like we have all these connectors to all the different instruments. They're standalone server applications, and we can actually fleet manage them. So you know exactly at any point in time which instrument is down, what actual API calls are being run to that instrument. And you can manage that from anywhere, from your own private cloud or wherever. So that's the first layer that we see. And then the next layer is like, okay, where does this connect to? And there should be some integration platform, basically one platform that homogenizes all of these interfaces. So there's like a layer where everything is connected to. And then if you want to build different applications and put them on top, then you don't have to redo the integration. So the integration is something that sticks, that's reusable, it's more sustainable, that also enables you to move faster between different projects or like reassembling your setups. And then on top of that, I think there are a bunch of building blocks that every lab needs. One of them being like an S3 compatible storage, like just an S3 bucket where you dump files, like a data lake. The next one being like an SQL storage. Something that you use to just put your structured data to, and then something that can run and execute code. And then on top of that base layer, you have all the different applications, be it your custom built LIMS, your LIMS off the shelf, your scheduling software, your front end, your dashboard, your operator interface. So I think the way that labs should look at their software infrastructure is in these layers so that they become decoupled. So they don't log into one vertical solution from one vendor, because it's incredibly difficult to break out from that. And what we currently have is not this layered approach. We have point-to-point integrations everywhere. You have different instruments being integrated into one software. If you change that software, you need to reintegrate the same device. Oh, yeah. You have that software being integrated into this database, into that database. And then if you change one piece, everything is kind of gone and you have to redo it from scratch. So I think this modular and composable architecture, this API first architecture is, I think, the way to go.
Yeah. I think if you're having to relook at a driver for every project, it's not a driver. It's just code that you can use here and there for stuff. So I mean, that's and where does AI not belong? in workflows.
Looking at the last layer that then actually sends something to the instrument. So there should be something in between that's validated, something like a compiler. So you can have code that says move a plate from A to B. That thing should just not be executed directly by an AI, but there should be something in between where someone has kind of validated the way that the code was written.
Move from teach point XY to teach point XY.
Yeah, and for example, that there's also error handling in there, and because if you let AI generate that code at every level, then there's no validation. Like anything could happen. So there should be like the lowest level.
Any
of
mistakes get compounded
actions.
Also, right?
Yeah, and then these atomic actions, I think they should be defined by a human in a way. You shouldn't just tell an AI, write some code and then just vibe code it and then run it and then something breaks. So there should be like a last line of defense there.
Helical Brew PSA, humans are still important.
Don't worry. We're still important. So I think all of our discussions so far we can wrap up in a number of ways with, the future lab is a system, not a collection of things, right? At the end of the day. And this is all going to be impacted or all going to be possible with the LabOS interfaces and also the future lab team, right? I mean, there's going to be, while we're still relevant in the lab, us humans, right? Maybe the job's going to change a bit, right? But I wanted to start out with, if you were to do the elevator pitch for the lab operating system, what does the true lab operating system enable that existing solutions never will?
5 seconds. I give you 5.
Oh, sorry.
It should have full low-level control and visibility. No black boxes, and it should be written with best software engineering practices in mind. So everything should be scalable like software. And this is something that right now I don't see any other solution out there actually provides.
And how do you see the role of the scientist changing over the next decade?
Yeah, they're going to have to get more skills, right?
Not necessarily. I mean, AI is moving so fast. I think they'll get enabled quicker than they think.
It's moving fast, but you still have a ride. Don't worry.
I mean, obviously, learning Python is always a good thing, and most scientists are already familiar with that. I think AI is actually enabling them to do more automation. It's lowering the threshold, I think. So instead of having a bunch of low-code, no-code, drag-and-drop tools, I think the interface will change dramatically for these scientists. And I also think that there will still be this automation engineer, actually also a DevOps engineer, I think. I think a good team also has a DevOps engineer in the future in lab automation. But the scientist will then kind of write or describe its scientific intent, and then he can already use an AI to help with that, and then it will be handed over to an automation engineer that has like an AI that's kind of helping him to turn this into executable code. So I think it's more of an enhancement and augmentation, and then at some point maybe for small and simple protocols, maybe a scientist can even build this entirely just with the use of AI and without having to learn a complete new language or getting training on a new tool, software.
I just want to step in here and just kind of challenge that a little bit, because I think scientists at their core, their career and their education is around scientific investigation. I'm a biochemist, I'm a biophysicist, whatever they are, they're interested in that. They get their PhDs in that. They're not necessarily looking to be software dev, automation engineers. I think their role for walking up to an instrument is presenting that biological construct to be worked on. The lab automation engineer, I think their roles are going to change, right? Because they're going to move with this tide of AI. But I think any scientist will say, hey, I didn't get my PhD for this, right? Unless that's where they're trying to go.
Yeah, true.
And that's also the way it should be. Like the scientist shouldn't do all the lab automation stuff. And right now, if you look into our field, every single person that is doing lab automation will tell you the same answer to the question, like, how did you get into this? And the answer will be, well, basically, I was the last one to put up my hand. So
yeah,
okay,
we all kind of became that, right? But you have to want to do that. Yeah. We just don't want to assume that scientists are going to come in on this tide. We still have to provide UIs and dashboards that make it easy for them to approach the system, but they're not going to be the real architects unless they want to, right?
Yeah. I think if I were a student at TU Munich, I would really enjoy you coming in and speaking, to a group of students, because I think it just shows, when I was a student, I remember the talks that I heard from industry folks coming back to school, and talk to kind of classes was, the most exciting things were about how I can do it right now. Like I can get involved right now, right? And a lot of things, like if I wanted to touch SolidWorks, company's going to have to pay a $20,000 license fee at that time. In the 90s, it's crazy. Like,
Yeah.
how am I going to participate? Well, the answer is you're not, because as soon as you leave that college campus, you can't play anymore because you don't have access to the college license of SolidWorks anymore. And these kinds of things. So if when what you're talking about is something that people can get behind, if you were to give them advice on, these are the skills to focus on to take, if you like what I'm talking about, you want to get involved in this, what would those be?
Also call TUM and see if they'll book you as a speaker.
Actually been there, done that.
There you go.
Oh, there we go. I wish I was there. Cool.
I mean, I would definitely tell everyone to at least take some programming courses, because if you know what's possible, you know what's possible. And right now, like if you haven't never taken a programming course, then you come into the lab and you don't even know what you can do. So it's more about not necessarily becoming an expert, but understanding what's possible. So I started out as a chemical engineer, then did bioprocess engineering. I had 2 semesters of programming in, I think it was C++ back then. And then we had a cool automation course, but that was it. First year, second year, and then afterwards, never again. And then during my master's, I kind of started getting into Python programming, and then during my PhD time, I was basically becoming self-taught software developer. And just by diving into all of these things, and I then realized there's so many things that you can do. And now at my company, I'm not allowed to write code anymore, because I realized that actually people like me are like part of the problem in this industry, because there's so many scientists that then kind of realize, oh, I can build so many things, and then suddenly that PhD thesis turns into a product, and then there's a piece of hardware, and then it's being used for the next 20 years. But then taking a step back and saying, okay, now I know what can be done, but then getting someone in that actually knows how to do it right. But then
Exposure.
Rise on.
That's a good
exposure.
point. Yeah.
So what would be one thing that you think the industry needs to unlearn as far as a belief about automation when they walk into it? Just your average kind of thing something that comes up frequently. What that's
makes
annoying.
your job harder.
That's annoying. Makes their jobs harder, and people need to unlearn it.
I'd say we need a mentality shift, like more of a can-do attitude. Maybe this is more here in Germany, but a lot of people, they think, oh, automation's hard. It's actually, it's not that hard. It's the same when...
so hard. Please pay us more to do it.
Yeah, it's the same when you show a biologist really difficult differential equations, starts setting shivers down their spine. But actually, if you look at it, it's not too complicated. It's the same with lab automation. A lot of people have this first response of oh no, I don't want to do this. This is too complex. I think we should shift that, and I think we're more capable than we think we are. And then oftentimes a small error is actually something that can be handled, and automation should be your friend and not your enemy.
I definitely like that. It should be your friend and not your enemy. But maybe we can qualify it less about, hey, differential equations aren't hard, because I think you undercut your point.
Yeah, sorry, that's my engineering background kicking in.
The book was this thick in that class.
I take that back. You're right.
It's going to be my cold open. Lukas saying differential equations are not hard.
It's easy. Fourier transforms, multi-order. Yeah, it's great. Awesome. From my perspective, orchestration is like plant management software in a way. Like if we look at a lab automation tool as like a miniature version of a factory, in terms of all the little things that are happening, I look at orchestration as like largely an interface problem. Is that what this operating system also is addressing? I mean, am I correct in saying that the interfaces need to mature and evolve to make orchestration a reality? Because I feel like orchestration is every vendor, or every time I hear it from a vendor, it's a slightly different angle on what it actually is. You know what I mean? And kind of like how it ties in and to what degree it ties in. Oh no, there's exceptions here.
They try to own it from their perspective.
They try to own it, but it's like you can't really own it because you can't really.
They shouldn't.
Yeah, don't try. Is that?
Yeah.
Yeah. Okay.
I think they should just make sure that the interface is well documented and that everything is accessible. And this is kind of where the responsibility stops, because they don't know what that instrument is going to be used for. And oftentimes, I rather have really great documentation and a really well designed interface than, I don't know, the 10th solution on top of it that does something that is not what I want. So I see that this entire industry is modularizing, but there will be a few more players in between that basically do this. So it's the same with if you look at an integrator from the past, or the early integrators, they did everything. They started building hardware because the hardware wasn't available. They're still doing that. Then they started building software. They started building benches. So they're doing all of these things. And the way I see it also going forward is that there will be more and more companies that do one of these things right. And by focusing on interoperability, then that would actually make all of our lives easier. And it's the same with orchestration. There should be interfaces. They should be well defined. There should be an integration platform. Then there should be libraries on top, all from kind of different players, or at least not all from one player. And then that next layer should kind of provide everything, like the resources. Are instruments available? The fleet management part. Is the device online? Are there any restrictions on this? Are there limitations? Is it booked? These kinds of things. That should come from like your infrastructure. And then all you need on the orchestration layer is then basically just the algorithm that kind of moves the needle. And then this should also be replaceable. Right now, if you go for one orchestrator, it basically provides you with the full stack all the way down to the driver. And that makes it incredibly hard to change. And maybe you just want to run a different optimizer. I mean, you get some modeling software, for example. You can typically choose the algorithm that you want to use for your optimization. It's kind of the same thing. If you have a scheduling problem, or even a dynamic scheduling problem, you may want to switch your solver because you have different problems. And I think in the future, we should go more towards like interoperable, smaller components that are provided by different companies that really focus on that aspect.
I feel like that would help those companies sell more than they currently do. Because right now
Yes.
you have to like commit, but if you
Yeah.
can just like pick and choose the best, right, you can probably sell more.
Play nice.
Play nice. I like it. I like
I
it.
think the whole industry needs to learn that because it's all about like, how do I capitalize, right?
Yeah, it's like the story from the past where, like, okay, I want to build a walled garden that basically does everything. You can't do everything, not in this industry, because there will always be this one device that you don't have in your portfolio. And there will always be this one scientist that says, I need the other plate reader because it has this tiny little different feature. And then suddenly the walled garden is,
Or they want an industrial solution for a lab solution. And some people have never done that.
Yeah, and there's a point of view factor here too. I mean, you can going into it saying that a walled garden is going to, work. I mean, look, we're working with scientists here. This is a somewhat chaotic environment, especially when you're designing the experiment. Scientists it can be to an outsider quite a chaotic environment. I just don't see the personalities being, like, okay, now let's put everything on the rails when they were just free thinking, brainstorming on a board in a meeting room. It just seems like counterintuitive with the culture of science as it
Very
is, right?
true. Very
It's
true.
such an experimental thing, right? You like say engineers engineer it this way, that just doesn't work. And I was wondering what your thoughts were on this as far as the users, the adopters, the folks that are going to be working with these technologies day to day. Would you say, somebody said this, I thought, begin your search for technology with ownership in mind, and I thought that was really applicable to this industry in that, well, if you want to really take a tool that you're getting from, support from different companies, different software vendors, maybe even a hardware integration company, whichever, beginning that process with the fact that at the end of the day, you're going to be able to do just about anything you want to do without picking up a phone eventually, with time. Would you say that is kind of where we need to go with these things for
100%,
users?
100%. So we're actually aiming to enable self-service. So documentation helps, tutorials, guides, videos, but also the product itself should be intuitive, kind of tell you how it wants to be used. I think you mentioned something else, like you should start thinking of like ownership when you're picking your instruments. I think you should also double down on the requirements that you hand over to the vendor. And something like open interfaces and interoperability should not be a nice to have. It should be in there, and you should tell the vendor, well, if you don't provide this interface, then I'm just going for someone else that does. And I think also the users, the buyers that buy equipment in the end, they should hold the hardware vendors accountable for that as well, because it's a huge lever. And the only thing that moves the needle for these companies is basically in the sales department knowing like, okay, this is actually impacting sales. We need to open things up. So this is also another one that if you're ask for that and make it a requirement.
Yeah. Yeah. As somebody who's been on the customer facing side for so many years, if I were to write a book for customers, the first chapter would be leverage your position. Laying out the requirements is something that's expected at the very beginning, right? Folks are listening, and it's important to take advantage of that time with a vendor to project that, because that sets the stage for everything. And it's not like 3 weeks into the project, oh, yeah, I was wondering if you could interface with this, the thing
Yeah.
and whatever it is, and just setting that up front. I just, like the highlights from, as I was saying earlier about the website, it's like, these are all things that you should just like have on a short list of, have we checked all these boxes for buying a piece of equipment in general, whatever it is. And yeah, no, that's
Yeah.
going to be a huge, huge transition, I think, as the industry gets smarter about it,
Oh. And there's also something that everyone can, we should start working together, because oftentimes it's also then on the vendor side, they may not be aware that this is a problem that they have across the board, because there's little visibility. If one person asks it here, the other person asks the other sales rep, and maybe it's not that visible. But if there's multiple people asking at the same time, then suddenly it becomes more important. And then they realize that also like, oh, this is actually a requirement we should start caring about. So sometimes also it's difficult for the vendors to pick up on what they should focus on at that time.
I mean, that's a big problem all around, right? Like we're talking in this one aspect, but we're still getting people who are trying to go from manual things that aren't automation friendly to automation. And there's a cost there, right? If you don't want to switch your consumable, then the custom stuff's going to be way more expensive than if you wanted to redo all the, scientific validation on automation friendly consumables. And that's still a disconnect. There's a lot in this industry that still needs to get fine-tuned even before you're an AI-ready lab, right?
Well, I am super excited to see what's happening in UniteLabs' future and what you all are doing. I think it's great for the industry. So, yeah, excited
Check
to
out
see
our
more.
booth. We're in Boston.
And that leads us up to what's coming up next. Before we get to the pick of the week, let's highlight that. UniteLabs, make sure you bring your heavy
In February.
down coat to SLAS Boston in early February at the Boston Convention Center. But it's just, we have a little segment towards the end of the show that we call our pick of the week. And I mean, there was a lot of different angles you can take here. I'll leave it up to you. But, is it a standard protocol concept, even a tool that every automation team should be aware of that is a daily driver for you?
Or something you're reading, or some cool gadget you picked up in your smart home. Or your favorite coffee. We go all crazy.
We all survive on coffee. No, not all of us.
We could always have Mike start, but we give our guests our opportunity.
Yeah, you can think about it. I can do it. My pick of the week is very easy. It's just go ahead. No, it's cool.
I mean, I'm not making any advertisements here, but Claude Code.
Claude.com.
Oh, the AI. Yeah.
Yes. I mean, I do a lot of prototyping, and I think it's incredible how quickly you can get to working things. And if you actually pace yourself and do things thoroughly, plan properly, and don't try to get to a working product with one prompt, I think it's incredible what you can do with that. Like building a new front end, like something user facing, operator facing, you can build this super fast. And I use that all the time, even just in the console or in my own IDE. You can even also use that, use it online. There's a web app for it. So try.
I do find it understands what I'm trying to get across faster than ChatGPT.
Yeah. And also it's fully integrated into your IDE and knows all your code base. It gets better every week. And I think everybody in lab automation should kind of start getting into that and like leverage that for building some custom apps that solve a pain here, pain there.
Yeah, a reasonable price point. I'm just looking at their pricing here for it's fairly reasonable. Like it's funny how you're paying Pro, Max 5X, and Max 20X are the tiers. It's like only in. The
problem is each one is good for certain things, and it's like, are you paying for them all just to get something that feels like a partner?
Yes. How much bandwidth are you getting at the data center? It's just wild to think about, even 10 years ago, none of this was on our radar as far as how we talk about product purchasing. It's like, it's kind of funny to see it all like that, but that's cool. No, I'll dig deeper into that.
Pro tip, put boundaries in. Like, you don't want an upper limit.
Yeah.
Because if you start working on that, like the whole weekend after, I've had multiple weekends where I was just like actually working on that or with it for like 16 hours straight.
Yeah,
Oh,
it's
that's great.
easy. It's easy to get caught
It's
up in
that
it
hooky. Okay.
because you get
Yeah.
so
All right.
efficient and productive, right?
Yeah.
Yeah.
And if you then
Amazing.
couple that with like Procurement charts, user charts, and then a Figma on the other side, you can actually build a complete product really, really quickly. And then typically this is like the first go. And then I think, okay, how can I now turn this into proper requirements? How can I now actually craft the user journeys and all of that? But that comes after this, like, okay, I actually want to understand what I want by having something that I can interact with immediately, and perfect for prototyping.
Sounds like we spend our weekends the same way.
That's great. I'm gonna do a deeper dive on that. Check that out. So great pick of the week. Do you have any other ones? It's not required to do more than one, but it's just if we leave it to our guests if they'd like to, because we've had one guest, I think something like 4 or 5.
Yeah,
It
yeah.
was a long
Just
list.
kept going. I had so many
Oh, I got
links
this
in
book
YouTube.
and that book and
Putting him on the spot, Mike.
I know. I'm bad. I'm terrible.
Fountain pens.
Okay.
Maybe odd one, but I really started cherishing that because I'm not sure. You probably type all the time. When was the last time you held a pen and wrote a page?
Not a
That's a long
page,
time.
but a to and from for Christmas.
Yeah, or maybe your signature, but that's kind of where it stops. And I recently got a fountain pen, and actually really like doing that. The other day I was writing some Christmas cards, and I realized, God, I don't know how to write anymore. Like my motor memory is gone because you're not used to writing anymore, and I thought that was really sad. So
That's true. I think the last time I wrote was on my iPad.
yeah, and now like if you have a ball pen pen, it's kind of normal, but then if a fountain pen, it kind of start cherishing the process. So
Yeah.
I can only recommend doing that just for the experience.
So when I worked for Stoibli, one of the gifts that we got was I have a Stoibli Mont Blanc fountain pen that just sits in a box, and you absolutely hit it on the head. I should take that thing on the box, because when you make a stroke, you get more than just a line. You get like character. You get almost like a little hump here and a little, something only
Actually,
a
I
fountain.
just
during Christmas
found
time.
mine. It has dust on it. That's how long it was since I used it.
Yeah.
Yeah, cool.
Christmas is around the corner.
Yeah. I
Write a nice
had
card to
one
a
go
loved one.
sideways on me. I'll never forget that. That might have been my aversion. It's a little OCD. I'm like, the thing exploded in my backpack, and it was not compatible with 30,000 feet. So,
the pressure. Yeah.
the pressure. I don't know. They've gotten better at the canisters have gotten better at dealing
Now I'm
with
all
the
dusty. Thanks,
pressure
guys.
and whatnot.
Sorry about that.
Well, those are two great picks. Love it. And Sura, do you have any picks?
I just showed you my fountain pen. I think I'm
Okay.
going to hop on
Pick of
that
the week was
bandwagon.
follow-up fountain pen. We had a follow-up fountain pen. My pick of the week is just easy. I think, it's just, yes, I've been involved with the organization for a long time, but, it's more for, anyone who's not aware, anybody who's being reached by this podcast and hearing what we're talking about, all this great topic of AI and the OS of the lab, if you will, and more topics. We're over 50 shows now. And, for folks listening to this that haven't attended an SLAS event, that's the most basic way to get involved with the SLAS. I would just say the SLAS registration for next year in February, students, folks with career goals, things like that. If it's something you hear about and you just haven't gone, and maybe you've got an opportunity to go, if you're in Boston or New England, that's pretty easy. If you got that opportunity, or if you want to fly in for it. I know some first timers are coming to the event. So slas.org if you want to register for that. It's one of the most reasonably priced events you can register for, with this amount of richness as far as meeting with vendors, hearing different talks. There's of course the conference path, which is more expensive, but even if you just go for the exhibition, they actually have speaking areas within the convention where you can, listen to different talks and hear industry folks talk about what they're doing and the future of this industry. So that's my
There's
pick of the
student
week.
pricing too, so you don't.
And
have
there's
to
student pricing.
pay
If
the
you're a
full-
student, they are very friendly to students. And something also I announce every year as part of my gig with SLAS, my volunteer gig, I announce the passport to prizes at the end of the show. And, somebody gets a free trip to Europe, SLAS Europe 2026, coming up in Vienna. Terrible place to be. Who wants to be there? It's a pretty awesome opportunity to go see one of the most beautiful cities in Europe, as well as go to the event, which the SLAS Europe has its own kind of path. It's a growing show as standalone in Europe. It has a slightly different theme to it. But either way, in the near term, Boston is coming up next, and then Vienna soon after that. So that's my pick of the week. SLAS.org if you want to register. And that's going to wrap it up for this episode of Helical Brew. Fantastic to have you on, Lukas. I want to give folks a way to reach you. What's your preferred place to connect? Is it LinkedIn? Is that your...
I would say LinkedIn,
okay,
or just by email, lukas.bromig@unitelabs.io.
Okay.
Lukas with a K.
Yep. Lukas Bromig with a K, a Bromig. And then we'll also have that in the show notes for both the podcast release and our other releases. Our primary platform is youtube.com, but you don't have to go to youtube.com. We make it much easier than that, right? We're just like Unite. We're trying to make it simpler to get to our podcast, right?
We're everywhere.
We're everywhere. Thank you, Sura, for putting us. We are literally on every platform I think you could possibly be on for video, and even a little bit of audio only, but we make it easier. All you got to do is helicalbrew.com. That'll take you to our YouTube channel. That's our primary venue for viewing our episodes and the wonderful shorts that Sura puts together that just keep getting better every single time. And we're also on TikTok and the other ones. But I think, if you go to youtube.com, you can connect with all those other platforms easier, or I should say helicalbrew.com. So that's going to wrap it up. We're looking forward to another episode in the coming weeks, and we're going to be recording more ahead of SLAS, and we're going to go for it again and record at SLAS. I think it's going to be a little bit easier to deal with there because things are closer, and I already know some spots where we can do it. So I'm looking forward to that.
We made sure we're in the same hotel too, so it'll be
made sure it's going to be easy. We've got a good lobby area, and who knows, we might get some impromptu conversations with showgoers coming back to the hotel. Hey, no, come on the show that way. You never know. So thank you everyone for joining us for another episode of Helical Brew, and we're going to call this one Brewed. We'll see you next time.
Thank you for joining us on the Helical Brew. We're glad to have you with us. For more episodes, please visit our website at helicalbrew.com. That's helicalbrew.com.